Hey, what's up, you guys? It's Miss Brothers. Just going to walk you through some of these problems on the stoichiometric conversions about moles and volume. So if you are wondering which practice this is practice number 3, and it's the one that's in yellow. All right, so before we get started on this, just remember, you guys, when we're talking about volumes here, we're talking about volumes of gases, okay? And we're talking about any gas that is at standard temperature and pressure, okay? So we talked about standard temperature and pressure in your notes, and so that's what we're going to be working on here. Now, the way this particular set of problems is set up, the first 5, what we're doing is we are trying to find, we are being given moles, and we have to find volumes. And then when we get through 6 through 10, we're going to be given volumes, and we have to find the number of moles, which takes us to 6 through 10 because there's actually a mistake on the copy. You can see right now all of these say grams, so you need to go through and change every single one of these. So 6, 7, 8, 9, and 10, you need to change that grams to liters. So just know that that's supposed to be reading liters, not grams. So we're going to take a quick second and just change those all to liters to start with. So I'm not going to do this entire one. I'm going to show you like the first few of both 1 through 5 and 7 through 10. And the reason I'm going to do that is I need to save a little bit of time because these videos do kind of take me a while, and I've got 2 sets of videos to do today, so we're going to hustle along a little bit. So we're going to start right here. We've got 1 mole, and we have to convert this 1 mole of, actually, you know what, I'm not going to do number 1 because number 1, it's just repetitive. It just turns out being the exact same answer. So I'm just going to jump right to number 2. So we're setting up number 2. We have moles, and we have to convert this to volume to start with. So what we're going to do is we're going to set this up just like we set up every sort of dimensional analysis problem. We're going to go 3.2 moles, and I'm going to use the abbreviation for mole, MOL. And again, I need to put my substance here of O2, and I'm just going to put that in parentheses. And I'm going to set that over 1 because we are setting up a ratio here. Now, I know I have to cancel out moles, and I have to finish with a unit of volume, which is liters. So liters has to go up on top. And mole, actually, that's liters of O2. And this is going to be moles of O2. I should probably actually put mole, MOL. There we go. And remember, I'm using one of these 2 ratios right here. So down here, I'm going to put 1 mole. And because I'm trying to find volume, it means I'm going to use this ratio right here. Now, unlike when we were doing molar mass, I don't have to look up anything on the periodic table here. Because what I know is that any gas, regardless of what it's made of, is 1 mole of that gas is going to be 22.4 liters as long as we are at STP, standard temperature and pressure. So I'm going to write here 22.4 liters. So like always, you guys, after that, it's just a matter of canceling out our units here and our units here. We have to multiply across, so we're going to end up, and I'm just going to write out the whole thing for this one. So it will be 3.2 times 22.4 liters of O2. If I take 1 times 1, that becomes over 1. And again, we basically just ignore that 1 when we're doing our calculations because anything over 1 is itself. So let's do the math real quick on this. It's going to be 3.2 times 22.4 equals 71.68 liters of O2, and that is the answer that I'm going to circle right there. Okay? So again, you guys, just remember in our dimensional analysis, we always put what we start with in our upper left-hand box here, and then we determine what's happening next. So let's do another one where we're trying to find, we are given moles, and we're trying to find the volume. All right, so we've got 0.750 moles of N2. We'll set that up over 1. And again, I have to cancel out moles, which means I'm going to use this ratio right here. So I'm going to go 1 mole of N2 over, or I'm sorry, under. So at top, we're going to put 24.4 liters of N2. Our next part of our process is we're going to cancel our units. We're going to multiply across. So we're going to take, and I'm just going to go ahead and do this one right in my calculator. So 0.750 times 22.4 liters. And I'm going to end up with 16.8 liters of N2. I'm just going to go ahead and check my math on that. 0.750 times 22.4. Yes, I love that answer. All right, I'm going to do one more, and then we're going to move on to our problems down here. So again, you guys, for this last one, we have moles, and we're trying to get to volume. So I'm going to set this up 1.75 moles of CO2. And again, you guys, it doesn't matter what gas it is. It could be a single element gas like, say, H2. It can be gaseous CO2. As long as we're at standard temperature and pressure, it's going to be the same, all right? So we're going to set that over 1. Again, we're trying to find volume, which means I have to end with liters on top, which means we're going to use this ratio right here. So 1 mole at the bottom of CO2, so we can do our canceling, and 22.4 liters of CO2 up here at the top. And yes, you guys, you need to write the substance every time. So now I can cancel out my mole of CO2 here, and I'm left with 1.75 times 22.4 liters of CO2. Let's go ahead and do the mathy math on that one. So it's going to be 1.75 times 22.4 equals 39.2 liters of CO2. And I'm going to circle that. All right. So for this next part, you guys, we're going to come down here and we're going to do a few of these. Okay? And for this one, we're going to be using our other ratio this time. Oops, you can't see that. Our other ratio, because we're going to be trying to find moles instead of volume. All right? So again, you guys remember we had to change these out because we had some typo issues here. So this should actually be 5.0 liters of H2 over 1. And now I have to cancel out liters, and I have to have moles on top. So I'm going to put my 1 mole on top. And again, you guys, I'm doing that because I'm using this ratio now. So I've got 1 mole over 22.4, oops, I forgot to put H2 here, liters of H2. And again, we go through that same process where we cancel our units first. And if we do our multiplication across, it's going to be 5.0 over 22, oops, I forgot my moles of H2 over 22.4 liters of oh no, I got to cancel out liters, that's right. So it's just going to be 22.4. And again, this time, you guys, you'll notice the difference. Instead of just doing our straight multiplication, when we do our multiplication across the top, it leaves us with some division that we have to do. So once we get to this point, we need to take 5 divided by 22.4. So let's go ahead and do that. 5 divided by 22.4 equals 0.22, and that's going to be moles of H2. Okay, that doesn't look like a very good 2. All right, let's do the next one. Like I said, I'm just going to do the first 3. So with this one, we've got 100 liters, and I'm going to put 100.00. 0.00 liters of O2, because that's what we are given. I'm going to set that over 1. And again, you guys, for these, I'm given the volume, and I have to try and find moles, which means I need to put my mole on top. And remember that if any gas at standard temperature and pressure, 1 mole of that gas is going to be 22.4 liters. And again, you guys, I'm dealing with O2 gas, O2. And now what I can do is I can do my canceling. I'm going to cancel my units here and here, which means I've got to take 100 mole of O2, and I've got to divide that by 22.4. So let's do that. So that's 100 divided by 22.4 equals 4. I'm going to take this to the nearest hundredth, so 4.46 moles of O2. Let's do one more. All right, let's go ahead and do this one right here. Let's do number 8. Again, you guys, just a quick reminder that this is supposed to be liters, not grams. So 28.0 liters of N2 over 1. Again, I have to be able to cancel liters, so that's going to go on the bottom, 22.4 liters. And remember, you guys, we are using that ratio right there, so that means that mole is on top, 1 mole. That way, our final answer will be moles. Okay, so we're going to go ahead. Oops, I forgot my N2. Going to go through the process of canceling my units. So now I'm going to end up with 28.0 moles of N2 over 22.4. If I do my math on that, that's going to be 28 divided by 22.4 equals 1.25 moles of N2. And there you go. So again, you guys, really what I wanted to do here, I wanted just to do the setup of these two different sets of problems. One where we're using the ratio that allows us, the top ones here, where we're using the ratio that allows us to finish with a unit for volume. And that second set, 6 through 10, where we're using this ratio that allows us to cancel out our volumes and finish with moles. All right, so if you have any questions on this, let me know. Again, I will post the key. So it's a good idea to try these problems on your own first, and then compare the key. And if you're not quite sure, you can go ahead and watch this video, and you can see the process. So if you have any questions, let me know.